All right, today we are reviewing the types of bonds. So just to refresh your memory on what a bond is, it's the attraction that holds atoms together. I always say it's like the glue that holds the atoms together. Two or more atoms can form a compound. For example, hydrogen and oxygen make the compound H2O. Here's a little flow chart. It's not perfect, but it works pretty well. If you've got metal atoms to the left of the zigzag, they are going to form metallic bonds. If you have a metal and non-metal atoms together, that's an ionic bond. And then non-metal atoms together, it can go two different ways. It can be network covalent, which is typically, oops, I didn't put it on this one. They're typically solids. And then molecular covalent is when you've got liquids or gases and all nonmetals. Again, you'd have to know a little bit more about the properties in order to decipher between the two, but the state of matter is a pretty good way. Here's a picture of each type of bond, and I'll explain why the picture goes with the bond. So for ionic bonds, metals, the ones with just white around them, give up their electron to nonmetals, so they have a negative charge around them. Now the positive and the negative charges attract. That's different from when metals bond. These are the metal atoms. They all give up their electrons so that they're just free-flowing, this sea of electrons. Network covalent looks like a quilt. That's because the atoms are sharing electrons in multiple directions, so they're held very tightly together. That's why they're typically solids. And then molecular covalent, same thing, they're sharing, but they're usually not so shared, like in all directions. So you can see why this would be easy for a molecule here to fly away as a gas. An ion, by definition, is something with a charge. So again, I was explaining this with a picture. In an ionic bond, metals give up their valence electrons to the nonmetals. So therefore, if you're losing something negative, you become positive. We'll talk more about this later, but that's because now there are more protons than electrons. So the protons, which are positive, they're winning. They're not being canceled out by as many electrons. Nonmetals are the opposite. They gain electrons. Since they have more electrons now than their protons, they have a negative charge overall. And because of that opposite attraction here, that's the glue that holds the atoms together. Some properties that you saw in the lab: they dissolve in water, they conduct electricity when ionic bonds are dissolved in water, and they do not conduct when they're solid. They're also brittle. Little joke for you, the name's bond, ionic bond, taken, not shared. Because again, in an ionic bond, one element takes an electron from another. Covalent bonds, they form when electrons are shared. They call these molecules. Some properties: they sometimes dissolve, they don't conduct electricity, and they're often liquids or gases. Network covalent, they form a network of connected atoms, hence the name. Those electrons are shared in all directions. Because of that, they don't dissolve, they don't conduct electricity, and they tend to be very hard solids. A joke about covalent bonds: thanks for sharing. Ha ha ha. Alright, metallic bonds again have that sea of electrons. Electrons are moving freely. Because of that, they don't dissolve, they conduct electricity as a solid, and they're bendable. A little bit more about ionic bonds. There are specific names for a negative versus a positive ion. A negative ion is called an anion, and a positive ion is called a cation. And we talked in class about how if you wrote this T as a plus sign, you can remember that a cation is positive because it has a plus right in its name. So why does water, not pure water, but why does tap water conduct electricity? Well, we're going to learn about this term lattice in the next set of notes. But when you throw something like a salt, NaCl, when you put that in water, the Na and the Cl separate. They're pulled apart by the water and they become these ions. So now current can actually flow through the solution. What kind of ions does tap water have? Well, my dentist always asks me if I've been drinking enough tap water because it has fluoride in it. Tap water can have other dissolved minerals, calcium, magnesium, sodium, chlorine. So you want to make sure that you're getting your ions in order to be healthy. And that is it for this set of notes.